Hey guys, hello everyone. Hi, how's it going everyone? Roshan, Christiana, Kush, Shubham, what else do we have? Good to know, good to know. Um, so quick question while other people also join in for all of you. If this workshop were instead of Indian time 7 p.m. to 9 p.m. or instead of the current time, if this started 2 hours earlier, 2 hours before, would that be better? Would that be worse? Would that be the same for you guys? Yes, as in, and what do you do, Shubham? I just like to get a sense if it's, uh, if these days for working individuals, this timing, 5 p.m. Indian time, whether that would work or not. Oh, that's the current time. I get that. If this were 2 hours sooner, and I'm not going to change it for the remaining 3 days, for the future, I'm wondering. Okay, okay. Personal work. So not work, but something personal. Huh? What about you, Kush? Nick, you'd be fine with. So what time is it in Singapore right now? And you'd be fine with 5 p.m. also during the lockdown, or would you be fine with 5 p.m. after the lockdown also? Okay. So it'll actually be better for you, huh, Nick? 5 p.m. For those of you who just joined us, I'm asking everyone, and I'm not, and again, to be clear, I'm not going to change the timings for the remaining 3 days. Uh, but if this workshop started 2 hours earlier than the time we started right now, so Indian time 7 o'clock, instead of 7 o'clock, we started at 5 p.m., 2 hours before the current time, would that work for you guys still? Would that still be a sensible time? Okay. So if let's say there were not a lockdown, Christiana, then what time would work for you? And you can tell me in your time zone, whichever way. Mhm. Your 7 to 9 p.m. So further 3.5 hours later. We started your 3:30 right now, right? So started your 7 p.m. Got it. Got it. Got it. All right. All right. Cool. Thanks for letting me know. I get some idea. Uh, One person who had a problem if the workshop would have started earlier. Apart from that, everyone else seemed fine. I mean, yeah, I mean, one reason I'm asking is I'm contemplating, I haven't decided yet, but I'm contemplating doing something like this in the future also. I'm also contemplating whether to keep it free or keep it paid this time. Yeah, a few variables I'm considering, but overall, I would want to do more workshops and actually refine it more also based on the feedback I've got from some of you people also through the feedback form, and also a few things which I myself felt we couldn't do very well. It was the first time for me also, so doing something in this format. So yeah, something which I realized while doing things. So for example, I would have liked to um, have more homework, but then that would also mean that perhaps taking some breaks in between, because 15 days back to back doesn't leave a lot of time for homework. But ideally, I would have liked there to be an opportunity for you guys to do more homework in between, um, more practice questions, things like that. And yeah, some few people pointed out that it wasn't very clear in terms of how it will be organized and what will cover, what will not cover. So yeah, that was also a point well taken, that there could be more clarity in that front, and that could be made more clear. One thing that few people mentioned was that sessions um, was could have been faster. And I think at least to the greatest extent, it was by design, because it's not like I had consciously decided that beforehand, but then while doing the sessions themselves, I think I kind of made up my mind that I'd rather make sure that most of you are getting what's being discussed instead of moving on just because a few of you have understood the things, but the rest haven't. And obviously, then there was a difference in terms of who's where in quant, who's where in sentence correction, who's where in critical reasoning. But overall, I mean, even some people who wanted to go faster, actually, I think even for them, because it's usually a habit, and that happens in my one-on-one sessions also. Many times, or not many times, a few times I find students uh, pretty much complaining that we did very few questions in a session. But then if we don't go to that level of depth, we actually can't get that much out of a session, right? So that's why it was a conscious decision, but I think at least setting expectations right in that sense could have been more useful. Significant dip in terms of participants from yesterday. We've had a uh, fairly even turnout for the last 4 days, and today certainly there's a significant dip. Wonder if it's because of the haha short push. Um, uh, just remind me once at around 8:45, 8:30, 8:40. We'll take it up towards the end of the session. Uh, all right. All right. Any questions with regards to what we discussed yesterday, or anything else related with GMAT before we get started? Okay, let's get into it then. So we were discussing that work question yesterday, and then I had left it halfway, and then I said we'll pick up from that point today. So that's what we'll do. This was the question we were discussing. Before getting into this question, I'd actually like to take a step back and look at another example. And I would like someone to have a conversation with. So again, not a lot of people around. Um, Whoever, Emmanuel, Christiana, Kush, Manik, Manit, Muthu, whoever uh, has no noise, Nupur, Pritesh, Shabdeep. Go ahead, guys. I think there are not too many people. So,
Hi,
whoever. Hey, who is this?
Emmanuel.
Hey, Manuel. Let's get one or two more. Rapdeep, Rakesh, Ramneek, Roshan, Shamit, Shamit Mittal. Shamit, is it your first session today, or have you been here before also? Any one of you is coming in for the first time today?
It's my first session today.
So how come, Shamit, how come you didn't attend any of the sessions before and you came in today? Did you
Uh,
about it or what?
Actually, I came to know yesterday only about this course.
How did you find out about it?
Yeah, it was reference from my friend, one of my friend,
Who?
uh, Mr. Pritish.
Okay, that's fine. I won't hold Pritesh accountable for anything. It's a free workshop anyway. That's okay. So you don't need to be worried about anything. All right. We're almost towards the end of the workshop, but still good to have you here. Um, yeah, I had closed registrations, but I think I mean, obviously, all you need is the link, right? I haven't actually put any restrictions. So That's fine. Okay. Good to have you here. I would like one more person with Emmanuel to take part. Come on, I think I pretty much took everyone's name, but
I am here, Roshan.
sorry, who is this?
Roshan.
Roshan. All right, let's go ahead. And Shamit, you can keep your mic on also, right? So this is what we usually do. I ask you guys some questions and then we discuss. All right. So Emmanuel, Roshan, and Shamit. All right, excellent. Let's get into it. Uh, Look at the two statements on top first. A lays 240 bricks in 8 hours. Today, A and B worked together and they laid 240 bricks in 6 hours. So these are the two given pieces of information. Now, based on these two pieces of information, any one of you three, in 6 hours, how many bricks did A lay? Oh, Shubham, easy. He's all right. In 6 hours, how many bricks did A lay? What's happening, Emmanuel, Shamit, Roshan? How would we calculate that?
Right.
Huh?
I would normally work out 8 bricks, the amount, the 240 divided by 8, which means 30 bricks an hour.
Okay.
It's 180.
And then 30 bricks in 1 hour. Therefore, in 6 hours, it would be 180 bricks.
Yeah.
All right. In those 6 hours, how many bricks did B lay?
Remaining bricks.
60.
I'd like the number, please.
60.
Okay. 60 bricks. Right. Because the two had together laid 240 bricks. If A laid 180, then the other guy must have laid 60 in that much time. All right. These bricks that B laid would have taken A how long?
2 hours.
Okay. Is that clear to everyone?
Yes.
All right. How does A's speed compare with B's? Who's faster?
A.
A is faster.
How does their time taken compare? Who takes more time?
B.
B. 3
B
times.
takes
Okay. How long would B take to lay 240 bricks?
60.
24 hours.
60 bricks in 6 hours, therefore 10 bricks per hour. And for 240 bricks, that would mean 24 hours. All right. Last question. What if we replaced 240 with 2400 everywhere? By everywhere, I mean wherever we have 240, we replace that with 2400. Now, so basically what I'm now saying is A lays 2400 bricks in 8 hours and so on. Now, how long would B take to lay 2400 bricks?
10 times.
10 times.
240 hours.
240 hours. Okay. Does everyone think so? What about the rest of you, Roshan?
I didn't get the question actually.
What did you not get?
Like, what are we trying to do? What if we replace
What
240
did
with?
you understand? What did you not understand?
I'm trying to understand the question.
I get that. But did you get any words that I said or did you not get anything at all? I guess you're distracted. All right, I'll continue. The question again is, what if we replaced 240 with 2400 everywhere? In that case, how long would B take to lay 2400 bricks? So would it be 10 times, Emmanuel?
Yes.
Everything times 10.
So again, how long did A take to lay 2400 bricks?
8 hours.
A took 8 hours. Together, A and B laid 2400 bricks in how much time?
6 hours.
Okay. Yet, B alone would take 240 hours to lay the bricks.
The time we are keeping same actually. You are just increasing 0. So the first two statements would remain, the time would remain same.
So how long would B take to lay 2400 bricks?
Okay,
Yeah.
okay.
No, how
It's still 24 hours.
24 hours.
24 because he's doing 300 now per hour.
Exactly. Exactly. Yes. Right. Because what we've done is we're still saying that in 8 hours, now they're just doing more work. But then everything in terms of time is still in the same ratio. In 8 hours, A could finish the task. In 6 hours, the two together could finish the task. And then how long would B alone take? So if I replace 240 with 2400, we realize that B would still take 24 hours to finish the job. Are we all on the same page so far?
Yes.
Yes.
And the rest of you, quick yes or no, please. Few more, quick. Yusuf, did you just join or were you listening to the entire thing from the beginning? Because you only changed the number of bricks, not hours. Okay, let me repeat. If you were listening also, Yusuf, let me repeat. So what I'm saying is, first let's understand the question very clearly. I'm saying let's replace the 240 with 2400 everywhere. So the first statement becomes A lays 2400 bricks in 8 hours. Today, A and B worked together and they laid 2400 bricks in 6 hours. Now let's continue actually from that point. In 6 hours, how many bricks did A lay? Christiana, Yusuf, whoever else did not understand. In 6 hours, how many bricks would A have laid now? 1800, right? Not 180, 1800. Because now, in 8 hours, they're doing 2400 bricks, and then in 6 hours, sorry, in 8 hours, A is doing 2400, and the two together are doing 2400 in 6 hours. So in A alone in 6 hours would do 1800. And then next question, B alone in 6 hours would do how many bricks? 600 indeed, the remaining. All right.
100, yeah.
Or how long would B take to lay the total 2400 bricks?
24 hours.
600 bricks in 6 hours, therefore 2400 bricks in. What happened? Emmanuel got it. Yeah, 24. Christiana, do you see that also? Muthu, Christiana, Yusuf got it. What about the rest of you? Yeah. So how long would B take to lay 2400 bricks this time? 24 hours. All right. Next, what if we replaced now 2400 with 24,000 everywhere? What if we add another zero in the number of bricks? Straight away, last question. How long would B take to lay 24,000 bricks this time?
24 hours.
24 hours.
Hours again? 24 hours again, indeed.
Yeah.
Right. So, similarly, what if I replaced this 24, 240, 2400, 24,000 with simply a variable X? Now, and if I replace it with X everywhere, A lays X bricks in 8 hours, together they do X bricks in 6 hours, how long would B take to lay X bricks? The answer would still be 24 hours,
24 hours. Yes.
right? If instead of X bricks, I call it A does a task in 8 hours, together they do the task in 6 hours, how long would they take? Or how long would B take to finish the task? Then what would be the answer? Emmanuel, Shamit, Roshan?
Sorry, can you just repeat that last part, Anish?
Now, everywhere I'm replacing these bricks with simply a task.
X.
Not even X, a task. A does a task in 8 hours. Together, A and B do the task in 6 hours. How long would B take to do the task?
24 hours till then.
24 hours, same.
4 hours again. So see, as long as, no matter what the task is, whether it's 24 bricks, 240 bricks, 24,000 bricks, X bricks, or 1 brick or 1 task, whatever that task might be, as long as that relationship between time is given, we can understand how long B would take to finish the entire job. Right? Whether we have more information about the job, that it's actually bricks getting laid, or we have no information about the job and we just call it a job. Either way, we can still understand how long B would take to finish the job. Right? Do the 3 of you get this?
Yes.
Everyone else, do you guys get this now? Come on, more yeses or nos, please. Well, now you guys know the drill. Come on. Okay, patience. All right, we will go faster. All right, now let's go back to the question we were discussing, and we'll try to relate that with this also. Take a minute, go through the question on the left side one more time. Just the question, we're not solving anything yet. 15 seconds more. All right, now let's get back to it. At 3 hours, X had dash hours of work left. What do we fill in there? X had 6 hours worth of work left. Right, indeed. Okay, let's put that in there. Oh, yeah. In 4 hours, in the 4 hours that Y worked, this is where we were getting somewhat confused yesterday. So let me ask this question this way. Whatever remaining work was there after 4 hours, if X were working alone, how long would X have taken to finish that remaining work?
6 hours.
No. So after, okay, let's put those times also. It's 12 p.m. is when X started, 3 p.m. is when Y joined, 7 p.m. is when they finished. What I'm saying is, what if X started at 12 and Y did not join? X started at 12 and Y did not join. At 7 p.m., how many more hours would X require?
2 hours more.
2 hours.
So X would have taken 2 hours more to finish the job had he been working alone. However, because Y came to help him, X did not need to work for those additional 2 hours, right? So the amount of work that Y did in these 4 hours is equivalent to the amount of work that X would have done in how long?
2 hours.
2 hours more.
Also, yes.
Yeah.
X could have finished that additional work in 2 hours, but Y came in, so X did not need to work for those additional hours. Y had worked for 4 hours. So in 4 hours, Y contributed X's 2 hours worth of work. Based on this alone, who's faster?
X.
Okay. And by how much?
X is working at twice the speed.
Twice the speed, yes. So if X takes 9 hours to finish the entire job, how long would Y take to finish the entire job?
18 hours.
Haha, how many of you all did not get that? Click on no if you didn't get this. Else I'll assume you all got it. Let me repeat quickly though. X, in 4 hours, Y contributed X's 2 hours worth of work. I'm assuming till this point we were all together. So in 4 hours, Y contributed, in 4 hours, Y did as much work that X does in 2 hours. In 4 hours, Y does as much work that X does in 2 hours. That means X is faster. By how much? He's twice as fast. He's able to wrap up the same work in 2 hours that Y takes 4 hours for. So he's twice as fast. Or in other words, Y requires double the time. What's the question?
Yes.
How many hours would it have taken machine Y to complete the entire job? We know that X would have taken 9 hours to complete the entire job. Now, where's this 2 by 3 coming from? We know that X can complete the job in 9 hours and Y requires twice the time that X requires. Therefore, if X takes 9 hours, Y would take 18 hours.
18 hours.
Pritish, where's this 2 by 3 coming from?
He's answering the fraction part.
I didn't ask a question related with fraction. Okay, maybe the next one, huh? Yeah, Pritish, that's fine. See, if you get this already, you don't even actually need to do the rest, right? If it's clear at this stage, so that's why I have the word or here. That was just another way of explaining the same thing. But if it's already clear to you that in 4 hours, Y is actually doing the work that X would have done in 2 hours, which then means that Y takes twice as long, then we are already done. Then we don't even need to get into the remaining stuff. All right, we all on the same page now? Do we get how we could actually get to 18 hours without even needing to put pen on paper? Again, let me be very clear. I'm not asking you guys to stop doing things mathematically. I'm definitely not asking you to do that. What I am asking, however, is that you add this layer of logic. So while you might still do things mathematically eventually, at least you understand what the answer should be like, what you are really looking for. See, as soon as you understand that when Y joins, they're actually taking 4 hours and X would have only taken 2 hours more, we already understand that Y is slower. If Y is slower, these 3 answers can anyway not be correct. And if we go a little bit further, we also understand that actually Y is taking twice the time. Again, don't even need to put pen on paper. Can you put pen on paper? Can you do things the mathematical way? Of course, I'm not going to stop you from doing that. That's not, I mean, no one can, but anyway, that's not what I'm trying to do here. What I am trying to do is introduce this layer of logic. All right, let's carry on. Okay, good to know. All right, simple question, and any one of you 3 can answer. 3 men can finish a task in 12 days. 6 men would finish the same task in
6 days.
6 days.
Not 24?
Half time.
They'll take half the time because it's twice the men. More people working would obviously then require fewer days. Right, good stuff.
Less days.
Good, everyone. No one got confused here. All right. My voice is breaking. Off goes my camera. All right. Is it better now, Kush?
Yes.
Okay. All right. All right. Next, let's talk about speed, distance, time for a minute. Now, no formula, right? We're not using any formula. And while there's only one formula and it's a very simple formula, but we're not calculating anything. Just from a real world perspective, I'm sure most of you drive, if not all of you. Even if you don't drive, you understand if someone's running, that person would be faster than someone who's walking. So we intrinsically understand what speed is. We understand what distance is. We understand what time is. So let's say someone's driving for the same duration at a higher speed. Would that person then cover more distance, less distance, or still the same distance than he would have covered earlier? If time remains the same, then he drives faster.
More distance.
Obviously, they'd cover more distance. That's what we tell our cab drivers if we are getting late for a flight. Please drive faster, I'm getting late. Because we have limited time and we need to cover that fixed distance within that limited time. So we intrinsically understand how speed, distance, and time work. Again, let's quickly try a few more. What if the distance is the same and the person drives faster? What would happen to time?
Time reduces.
The person will take less time, indeed. All right, next. What if the person needs to drive the same distance and needs to cover that distance in less time? What do we need to do?
Increase speed.
We need to increase the speed, indeed. All right. Again, I wouldn't even say them out. Take us through the rest. The fourth one, and if you're answering in the chat window, just write this number also, 4 dot, 5 dot. What about the fourth one? What about the question mark?
It's the same like third, right? No difference.
Okay, my bad then. What about the fifth one?
Speed increases. Distance reduces.
Distance reduces. How come?
This speed is same and time has increased.
So that person will now cover less
Okay.
distance.
More. Distance increases.
If you're driving at the same speed for a longer duration, you would cover more distance. Right? If you're driving at 60 miles per hour for 1 hour, and then instead if you drive at 60 miles per hour for an hour and a half, you would cover more distance. Okay, what about the last one? Oy. Again, no mathematics here.
Increases.
Cover more distance in the same amount of time. What would you need to do to the speed?
Speed has to increase.
You need to drive faster or walk faster. We know this. We all know this. It's all very, very logical, right? There's no mathematics required here. We clearly understand all this. All right. Let's try another variation of the same thing. Now, instead of simply increasing and decreasing, let's talk about multiples. What if we drive for a certain amount of time, but increase the speed to 2x, 2 times the speed it was earlier? What would happen to the distance?
Double.
The distance would double also. Continue, next one. Whoever's putting in the chat window, put the number also before. So 1, 2, 3, 4, 5, 6. Emmanuel, what do you think about the second one?
Time doubles.
Emmanuel, where are you?
I'm here. I'm here. Sorry, I just unmuted
Are you
myself.
getting what we're doing, or are you?
Yes, yes. I'm getting.
Why don't you answer the third one for us?
Okay. Same distance, half the time. Same distance, double the time. The speed. Double the speed. Same distance,
So see, let me
twice the
ask
time
you.
it took us. So speed was
If you need to travel the same distance, but you can afford to take twice the time, would you drive slower? Would you drive
slower speed. Slower speed.
by
Half the speed.
half the speed?
Half.
Right? Simple. Think of things this way. You need to drive to office, and today you can afford to take twice the time that you usually take. So it's clear that you would drive slower, and that too at half the speed. All right. What about the fourth one? Any one of you? You need to cover the same distance in half the time. What would you do to your speed?
Double the speed.
You would double your speed. Continue. Emmanuel, how would you put this one in words? The fifth one.
So you need to cover double the distance, but you're traveling the same speed.
Right.
Double the distance, same speed.
Then what's the question?
For time, same speed, double the distance.
Don't try to do mathematics. Just think about it. Your speed is fixed, but now instead of just driving from home to office, you need to go to office
Twice.
and then come back also.
Twice the distance, twice the time, sorry.
Twice the time, indeed. Right? I'm not asking you to think about the formula or any mathematics here. And I'm sure, I don't even need to ask you guys. I'm sure you all know this. You all understand this. We do these things day in and day out. If you're running late for work, we drive faster. If we are not in a rush to get back, or if we want to actually get back home after someone's left, we would rather drive slower. What about the last case? Roshan, could you explain this one in words?
In half the time, our speed and the speed is also like double. Distance would be 4 times.
Again, no mathematics. Think about it. You're driving at twice the speed, but you're only driving for half the time.
Okay, half of the time. So distance would remain same.
Yes, yes. And see, while we could very well do it mathematically, I hope in your mind also, Roshan, you were not using the formula, distance, speed into time to get there, right? Because we can all logically get this. If I'm driving at twice the speed, obviously I'll require less time. How less time would I require? I'd require half the time. So anyway, if I'm driving at twice the speed for half the time, I would cover the same distance that I would at X speed for X time. Correct. Correct. Yes. Do we all get how these things worked? Are we all on the same page?
Yes.
Okay. Come on, faster. A few more yeses. Come on, guys. Okay, new question. I don't like this. New question. New question. How many of us are active participants in the session right now? So we are all here. Wonder what happens with questions. 51. I don't know what that's. That's the answer to ask him. All right, let's move on. Okay, next. All right, let's all thank Roshan, Emmanuel, and I'm sorry, I forgot the last person's name, but he wasn't very active also. Thanks, guys. Maybe we'll call upon you again later on.
Sure.
Thanks. Let's get someone else in. Yeah, come on. I don't even want to say out names. If you don't have voice at your end, just turn on your mic. Come on, any one of you, even if you've been participating every day, doesn't matter. And
Hello, Anish. Yusuf.
Yusuf, yeah. I said this specifically for you, even if you've been participating regularly. I had a sense you might want to help out. Excellent. Hey, Yusuf. One more, at least one more.
Hi Anish, this is Manat.
Manit, excellent. All right. Do you guys drink, both of you?
Yeah.
Yeah.
Okay, I'm not offering any, but let's try to understand how drinks work. So we have two glasses, one glass with whiskey, one glass with water. Yeah, I should have actually painted. But anyway, let's assume this one here is filled with whiskey, and this one here has water in it. And I mix the two contents. How strong would the final drink be?
It depends on how much we actually put, right? Like if it's half whiskey, half water.
Right.
Or, yeah.
Right. So we would need to understand in what proportion have the two been mixed.
Yeah.
It could very well be one drop of whiskey and then rest all water or whatever, right? It depends on the proportion. Exactly. So similarly, I mean, if you guys drink, let's say one of your friends makes you a drink and gets it to you. Just by looking at the color, you can tell, oh man, this looks too strong. It's not fine. I'd like some more, some mixer in it. Or
Yeah.
right? Or by looking at the color, you might feel, oh man, it's become too mild now. I need to add some more alcohol to it, right? Just by looking at the color, we can tell.
Yes.
So we do understand how proportions matter in mixtures. And again, we all understand this logically. No, Emmanuel, it won't be 50% diluted unless we know in what proportion the two have been mixed. You assumed that they were mixed in an equal proportion, Emmanuel. I hope you get that now. All right. So let's just call it, since there's no fixed standards, how strong. From now onwards, let's use this terminology. If it's bang in the middle, equal water and equal alcohol, we'll call it M, medium. If it's very strong, we'll call it high. If it's low or not very strong, we'll call it low. All right, LMH. Let's try. What if the two are mixed? What if 10 ml of whiskey is mixed with 10 ml of water?
Then it's medium.
Okay, I think we're all on the same page. Next question. What if we mixed 100 ml and 100 ml?
Medium.
Also M, right? Is the same. Doesn't change just because we've increased the volume. As long as the volume of both those liquids is equal, the resultant strength would be medium, correct?
Yeah.
Okay. What about this case?
High.
This high.
This is high, right? Just one drop of water, just 1 ml of water in 100 ml of whiskey. This would be a very strong drink. All right. What about this case?
That's very low.
That's very low, right? It's pretty much water. Okay, we're all good so far. What about this case?
Still low, but comparatively higher than the other low.
Let's
No,
say,
I'd say this is between L and M, yani medium low.
so let's say this is a number line, right? So I think we all get that it's between L and M.
Yeah.
Now between L and M, is it closer to L or closer to M?
Closer to M.
It'll be actually pretty close to M.
Yeah.
Right, 99 and 101. But then could it be beyond M towards
No.
H?
No.
For sure not. There's more water, so it's for sure less than bang in the middle. It won't be more than bang in the middle for sure. All right, another case. What about this one here?
It's just slightly more than M.
Slightly more than M. So first thing we realize is that it's between M and H. Not just that, we also realize it'll just be slightly more than M, right? Very close to M.
Yeah.
It will be higher than M. It won't be lower for sure, but not by a lot. Not by a lot. All right. Let's answer one more question. So let's say we've added these two liquids, 99 and 101, into this class. First question, how much ml from this class do I need to pour out to make the solution, the strength bang in the middle?
Can you repeat the last part of the question? To make what?
I'll start from the beginning. So we have mixed the two liquids, 101 ml whiskey and 99 ml water into one glass. So now we have a mixture in this. What volume of mixture do I need to remove from this glass to make the resultant volume M? Bang in the.
Yeah. So no matter how much you actually remove, the concentration will remain the same, because now since they're mixed.
Right. Right.
Yeah.
So I can't remove whiskey separately or water separately.
Yeah.
Right. So yes, the concentration will remain the same no matter how much we remove. We get this, right? So we know how drinks work. We understand this. Also within the same, so now let's say I haven't removed anything, sorry. How much water do I need to add to now make the strength bang in the middle?
It's 2 ml.
2 ml?
Yeah.
Right. So as soon as I add 2 ml, now we get a 101 ml and a 101 ml solution, which is bang in the middle.
Yeah.
I think we all get this. I wonder why, but all right. Let's try a different scenario now. Here's my question. Let's say there are two classes in a school. The average weight of class A is 40 kgs of all the students in class A, and the average weight of all the students in class B is 20 kg. My question is, what's the average weight of all the students combined?
So if class A and class B have the same number of students, it will be 30 kgs. But otherwise, it depends on the number of students in class A and class B separately, because it will be weighted average then.
Okay, what do you think, Yusuf?
Exactly.
Right?
Yeah.
Do we all get this? Do we all get that unless we know the number of students in these two classes? And again, while it is weighted average and I have that heading here also, but let's not worry about the technical terms. Let's just try to understand it simply. If we don't know the number of students in the two classes or the relation between the number of students in the two classes, is it possible to calculate the average weight? It's not. Do you all get this? I know Yusuf and Manit get it. What about the rest of you? Quick yeses or no's? All right. All right. Good stuff. Now, what if there are 10 students each? Yusuf, Manit?
Then the average will be 30.
Yeah.
30. All right. Let's continue. What if there are 100 students each?
It will be 30.
30 again.
Not 300, huh?
No.
It'll still be 30. Okay. Let's continue. What about this case?
So it will be 1 upon.
Now we have to do it in a weighted average. So it's 40 times 1 plus
No
20
calculation.
times 1.
Oh, stop, Yusuf, stop.
Okay.
No calculations.
Sorry about
That's
So
okay.
now it will be closer to 20. Like
Exactly. That's what I wanted you to get at. So if there's only one student from class A and 100 students in class B, again, LMH, in this case, LMH become 20, 30, 40. First thing we realize is that the average would be between which range? 20 and 30 or 30 and 40?
20 and 30.
20 and 30.
Would it be close to 30 or close to 20?
Closer to 20.
Yusuf, do you get that also?
Yeah.
I think most of us get it. Right, exactly. And for this, we don't need to do any calculations. It's actually identical to what we were doing with whiskey just 2 minutes ago, right? It's like one drop of 40 kgs versus 100 drops of 20 kgs, right? Very similar situation. All right. What about this situation?
Closer to 40.
Could it be beyond 40?
No,
40
No.
point something, 41 something?
it can't be.
No.
So it would probably it will be 39 point something or 38 point something, right?
Yeah.
It'll be something quite close to 40. So again, we understand right away that in this case, the average would be more than 30. When would the average be 30?
Or when the number of students are the same.
When the number of students are the same. In this case, since the class with the higher weight has more students, the average would be more than 30. That's one thing that we understand. Also, since the number of students are so close to 40, sorry, what am I saying? Since almost all students weigh 40, the final average would be very close to 40 without going over. It can never go beyond 40. All right. Okay, one more question. What if this one guy were not there?
Then the average weight would be the weight of class A, the average weight of class A,
Which
which is
is
40.
40. So would the average weight of all students combined be higher if this guy is there or if this guy is not there? The class B guy.
If he's not there, the average weight will be higher. If he is there, it will be
Yeah.
lower.
Right. Yusuf got it also. Do you all get this? So this guy is actually bringing down the average a little bit. He's 20 kgs. Not by a lot because it's just one person as opposed to 100 people on the other side. But he's still trying and he's at least pulling it towards him a little bit. At least a little bit. These guys are not allowing him to pull a lot because he's on his own. These are 100 people. But then still, the average would definitely not be 40 anymore after adding this person. It would certainly be less than 40. Right, Manit, Yusuf, we get this, right?
Yeah.
Yeah.
Okay. Next, what about this case?
So it will be close to 30, above 30, but very close to 30.
Yusuf?
Yeah. Exactly.
Close to 30, Shubham, yes. More than 30 or less than 30?
Slightly more than 30.
Why most likely?
Slightly because there is only a difference of 2 students in both classes.
Did you say slightly or did you say most likely?
Slightly.
Oh, okay. I heard most likely. So would it be more than 30 or less than, slightly more than 30? That's what you said. Got it. Got it.
Yeah.
Right. So 20, 30, 40. Since there are more students who weigh 40, the final average weight would be greater than 30. That's one thing we understand. The other thing we understand, because there's a very small difference. Right now, let's visualize a tug of war. There are 101 people pulling on one end and 99 students pulling on the other end. So it's actually a lot closer. So it actually won't be very close to 40. It'll actually be very close to 30. Slightly more than 30. Maybe 30 point something, 31 point something. Are we all on the same page thus far?
Yeah.
Okay. And Yusuf, I hope you get that we actually didn't need to do any calculation at all to understand all this.
Yeah.
Okay. All right. What about this case?
Slightly lower than 30, 29 point something.
Yusuf?
Exactly.
All right. I'll assume that everyone else also got it. It's the same thing, this time I've increased the number of students in class B. Do you guys also see that things actually work the same way for weighted average as they did for mixtures? Right? Just the way things were working for whiskey and water, they're working the same way here also. right? There also we were discussing a little bit more than m, just a little bit less than m, or very close to L, very close to H. And those are exactly the things that we're discussing here also. Manat, Yusuf, do you see that relation?
Yeah.
Yusuf seems lost.
No, no, no. I'm fine. I'm great.
All right. Okay. I'll assume everyone else also saw that relation. Okay, we're not, and again, no mathematics, please. No mathematics at all. I know most of you can solve this using maths, but that's not what we're doing. We're not simply solving, we're trying to build logic. Let's look at these two statements. I'll read them out for you. A man travels at 40 miles per hour for 1 hour and 60 miles per hour for 1 hour. Versus, second scenario, a man travels from A to B at 40 miles per hour and then from B to A at 60 miles per hour. Would the average speed be the same in both these cases?
No.
No, it's the same.
So one person saying it'll be the same and the other saying it will not be the same, is it?
Actually, it won't be the same. Yeah.
It won't be the same.
Okay, why not?
Because here we know that 40 miles per hour for 1 hour and then 60 miles per hour for 1 hour. So the average speed will be 1 hour itself.
Average speed is hour.
I'm sorry. The average speed will be 50 miles per hour.
50 what?
50 miles per hour.
Be careful of the units.
Yeah, miles. It's miles only.
Miles per hour.
Yeah.
Okay. What then?
And in the second case, a man travels from A to B at 40 and then B to A at 60. So we don't exactly know how much time did he take. So again, we don't know.
So we can't calculate this average speed. Is that what you're saying? And again, I don't want you to get into any mathematics. Let's be very clear. But just by looking at this, what do you think? No mathematics.
Oh, no, we can actually, since the distance is the same. So the average speed should also be the same.
Should also be
Yeah,
this.
it's going to be 50 as well.
Yeah, it's 50.
We are back a full circle. Now we think it'll be 50 in both these cases. And again, I know you guys, many of you can solve it using maths, but please do not use maths, right? Let's just think about it logically. And Mayank, feel free to type in the window, anyone else. Quite a few of you earlier said that the speeds would not be the same. If you still feel the speed would not be the same, please explain in the chat window. I might ask one of you to turn on your mics, but start off in the chat window, please. Time is constant, distance is constant. Get that, Emmanuel. How does that matter? How does that impact? So both of you think that the average speed would be the same in both cases?
No, I think average speed is calculated on the basis of time and not on the basis of distance.
Okay. So let's understand this. Let's not solve. Let's understand. Let me ask you this. Let's say you're going from home to office. This is home, and yeah, this was all before lockdowns. Let's say you're driving from home to office. For the entire duration, if you drove at 60 miles per hour, then your average speed is 60 miles per hour. Right? That much is clear.
Yeah.
Okay. Next, what if for, let's say, and overall, let's say it takes you close to an hour. Let's say for 55 minutes, or for, yeah, let's say for 55 minutes, you drove at 60 miles per hour. And then for 10 minutes, you had to drive at 30 miles per hour. Or not even 10 minutes. Let's say 1 minute. 59 and 1. Let's say. Let me write the number. I can't see. Let me cross them and write them again. So here's what I'm saying. You drove for 59 minutes at 60 miles per hour, and you drove for 1 minute at 30 miles per hour. What would be the average speed in this case? For the
Slightly less.
Slightly less than 60.
Yeah.
quite close to 60 though,
Yeah.
right? Okay, let's take the other extreme, 50, and these 59 minutes at 30 and 1 minute at 60. What now?
Slightly higher than 30.
Just higher than 30, very close to 30.
Yeah.
Next, what if you drove for 30 minutes at 60 and 30 minutes at 30?
45.
Now the average speed would be 45 miles per hour. Okay, we all see this. And that's
Yeah.
what's going on in the first scenario.
Yeah.
The time at both the speeds is the same. Therefore, the average is the simple average, which would be 50 miles per hour. Again, we're not solving anything, we're just understanding. In the second scenario, can we say anything about the time?
No.
No.
No,
So
really?
we can say that from A to B, we took more time as compared to B to A. So we
First of all,
traveled
can we
for
say anything about the time? Yes, we can.
yes.
It's not like we can't say anything about the time. Again, all right. What can we say about time? Manit, repeat that, please.
That from A to B, it took us more time to cover from A to B than it took from B to A, because from A to B, we were traveling at 40 miles per hour, and from B to A, we were traveling at 60 miles per hour.
Okay, let's stop here. Is this clear to everyone? Just because
Yeah.
A to B, the person drove at a slower speed, obviously he'd have taken more time, and B to A, he would have taken less time. All right. By virtue of this, Manit and Yusuf, can you now tell us whether the average speed would be exactly 50, more than 50, or less than 50?
It will be less than 50.
Aha, why so?
Because we are traveling for more time at 40 miles per hour than at 60 miles per hour. So if it was the same time, it would have been 50. But since we're traveling more at 40, and it's between 40 and 50.
Yusuf, do you get that also?
Yes.
Does everyone else get this? So what did Manit just say? That the average speed would be less than 50. In other words, it will be between 40 and 50. If you don't click on no, guys, I'll assume that you got it. Even if you don't click on yes. Isn't this also very similar to mixed, that whiskey thing and the weight and the students thing,
It is.
right? So how is this working now? Like you understood eventually, Manit, that what's pulling the average speed towards itself is the time that the person has driven at that speed for, right? If I drove at a particular speed for 59 minutes and I drove at another speed for 1 minute, that 1 minute would have had very little contribution. 59 minutes would have had a much higher contribution. In this case, the average speed would certainly be less than 50. Where did we get that number 50 from, Manat? Explain one more time.
Since we know that we are traveling for more time at 40 miles per hour than 60 miles per hour. So if the time was same, the average would have been 50. But since we're traveling for more time at 40, hence it's between 40 and 50.
Right. So I'd like to highlight this again. If the two traveled for the same time at 40 and 60 miles per hour, then the average would have been 50 miles per hour. 50 miles per hour, not later. Right? But if now the person travels or spends more time driving at 40 miles per hour, which he would to cover the same distance, then the average would be lower than the average, or the average would be closer to 40. Let me say this. Closer to 40, in other words, farther from 60, in other words, between 40 and 50. It would certainly be less than 50 and greater than 40. Would we still need to solve it? We might, if there were a question like this. But at least we get a fair sense of what the answer needs to look like. Right? And that's the point. Could you guys solve it using mathematics? I'm sure you could. Either one of you or anyone else, could you tell us what's exactly the average speed in the second case? Now use mathematics. Hmm. Yes, Kush.
Yeah, it's 48.
Yeah. How, Manit?
So, like I just took the distance to be something and I solved it with the formula.
Tell us.
So let's say the distance is 100 miles.
Let's call, okay, continue. I'll call
Or
it D.
actually, let's take the distance to be the LCM. So let's say the distance is 120 miles.
Okay.
And from A to B, we traveled at 40 miles per hour. So it took us 3 hours exactly.
Yeah.
And from B to A, we traveled at 60 miles. So it took us 2 hours.
Okay.
So the average would be 3 by 5 into 40 plus 2 by 5 into 60. Since the total time taken is 5 hours, which is 3 hours from A to B and 2 hours from B to A. And so 3 by 5 into 40 plus 2 by 5 into 60.
Okay. All right. I see it this way. Here's another way in which I get it. If we were to solve it mathematically, let's say the distance is D. What's the total distance? Distance from A to B is D, let's say. What's the total distance? 2D.
2D.
Okay. What's the time taken to get from A to B? Distance upon speed.
3 by 40. Yeah.
And then the time taken to get from B to A would be D by 60. This is the total time.
Yeah.
Average speed would be nothing but total distance upon total time.
Yes.
So 2D upon this weird thing. Now let's take an LCM 120 and then we get 3D plus 2D. And when we take a reciprocal and everything, eventually we get the average, and the D would get cancelled, we'd get 48 miles per hour. Right. Okay. So it is calculable, we can get an exact answer. However, what I was much more interested in was highlighting how we can actually get a sense of the answer even before we start calculating. And that sense is very, very useful, in my opinion, at least. All right, let's continue. And I'd assume, might as well, quick yes, no? All on the same page so far?
Yeah.
Okay. Done with this. All right, let's try a question. And I mean, you could go about it any way you want, but let's see. Can you at least eliminate a few answer choices in a short span of time? Go ahead, all of you.
Okay. So since we know that the average age is 35 years, there are more women than there are men at this party.
Elaborate.
So first,
Okay. Sorry,
so
continue.
yeah, so if the number of men and the number of women was same, if there were 22 men and 22 women, then for the average age to be 35, the average age of women would have to be 32.
Okay. Elaborate on this a little bit more.
So since the average age of men at the party is 38 years, then to get an average of 35 years of the entire pool of people at this party, the average age of the woman would have to be 32.
So the average age of men is 38.
Yeah.
We have to figure out the average age of women. The overall average age is 35. You're
Yeah.
saying if the number of women and the number of men were equal, then the average age of women would have been 32.
Yeah.
If number of men equal to number of women. Let's take a pause here. Yusuf, do you get this? Everyone else, do you get this?
Yeah.
More yeses or nos, please. Do you get that had the number of men and women been equal, then given that men's average is 38, the overall average is 35, then women's average would have been 32. This is 35 plus 3, that would have been 35 minus 3. 35 would have been the simple average, middle number. All right. Now what, Manit?
So here we know that since the average number of women are more than since the number of women are more than the number of men, hence the average weight. I'm sorry. The average age of the woman cannot be less than 32.
Interesting. All right. Let me just repeat what Manit said. Given that there are more women than men, this 35 would actually be closer to the women's average age compared with the men's average age.
Yeah.
Right? Had the two been equal, number of men and number of women, then the average age between men and women would have lied bang in the middle. However, given that, and sorry, I should have written here, women and men. Given that there are more women, no, I was right earlier. Whatever, given that there are more women, the average would actually be closer to the women's average compared with the men's average. Yusuf, do you get this? Everyone else?
Yes.
Quick, do you get this? Yeah, I think that, let me repeat this one more time quickly. Had there been equal number of men and women, then 38, 35, then women's average would have been 32. However, since there are more women than there are men, the pull towards women's age would be more. Therefore, this 35 number would actually be closer to the women's average than to the men's average. What does that mean? Since this is the number we have to figure out, we don't know this number. So can this number be less than 32 or equal to 32? No. Because if it were equal to 32, then the number of men and women would be equal. If that number were lower than 32, that would mean that this average is actually closer to the men's figure. That would mean that the men are more. Men are pulling the age more towards them. But since we know that the women are more, this number has to be greater than 32. Indeed. Therefore, without actually doing anything at all, we can at least get rid of 3 answer choices. And greater than 32, we can say that with confidence. It can't even be equal to 32, right, Manit?
Yeah.
That's not bad for 30 seconds of work. Think about it. And not even 30 seconds of work. We actually had to anyway read the question. After reading the question, if this concept, if this logic is clear, I don't think it would take even 10 seconds or maybe 15, 20 seconds, whatever. That's not bad, right? We're able to eliminate 3 out of the 4 incorrect answers just on the basis of this much alone. And let's say you were running out of time on the exam. That's a great situation to use something like this. Now you have a much better chance of getting the right answer. than you did 15-20 seconds ago. We'll not get into solving it right now. If we were to solve it, how would we solve it, Manit or Yusuf?
If we were to solve it, we were to solve it by weighted average formula. So
Tell us.
the number of men times their average age plus number of women times their average age over the sum of men and women.
So 22 times 38 plus 26 times, actually let me write this, 22 times, and correct me if I'm going wrong anywhere, men and men plus 26 times women's average age upon the total number of people, 22
48.
26
Yeah.
is equal to 38, right?
Yeah.
Is equal to 35.
Yeah, thanks. And then what we need to figure out is the women's average age. We can get that from here. All right. Again, could we have started this way itself? Yes, we could have. There's nothing wrong with that. I'll let, now I won't repeat it any longer. I'll let you guys decide whether you see value in applying logic before. What do you think so far, Manit, Yusuf? Do you see value in applying this kind of logic?
I personally see the value, especially if we're running out of time in the exam.
Yeah. So, but in order to get the exact question, we will have to solve it anyway. So,
Yeah.
Yeah.
And that's right. But then, see, think of it this way. Did applying logic actually cost you more time?
No.
oh no.
Once you get that logic, it won't take even a second. Explaining it, understanding it will take time. But once you understand the underlying logic, it actually, while reading itself, you'll understand all this. Then what's the harm? Right? It's not like we're losing out on anything. It's not like we could have used that time to do anything else. We didn't even take any time to do this. Right? And if we are able to eliminate three, see, multiple benefits. We eliminated 3 out of 4 wrong answers. Or think of it this way, even if we made a calculation mistake later on, we would realize right away, hold on, the answer needs to be greater than 32. How come I'm getting an answer lower than 32? Right? We'd notice all these things right away.
Yeah.
And in this question, we were able to eliminate 3. In some questions, we might actually also be able to eliminate 4. And then we'd be done. And we don't want to be in a situation where after solving, we realize, oh man, I could have actually simply used logic to eliminate all 4 answers, wrong answers in this case. Right? We'd rather not have that situation. Yeah. All right. Plus, it helps you understand what's going on a lot better. Right? It helps you understand what's going on, what these things physically actually mean. These all have a physical significance. Maths is just one part of it. For example, that's why I started with the drinks example, because that's very easy to visualize. Right? Just by looking at a drink, you can say, oh man, this is too strong. I can't have it. You don't need to do any math. You don't need to ask how many ml of water did you add, how many ml of whiskey did you add. You can just tell. Similarly, in all these questions and all these things, we can tell. And once we reach that stage, it only has advantages, no disadvantages. All right. Hold on. Let me just see. Yeah. Let's actually try to get someone else. Huh? Let's all thank Yusuf and Manit. Might need to call you back if they're not other participants. But for now, thanks, guys.
Thanks.
2, 3 more people. Again, anyone, even if you've participated before, doesn't matter. Just turn your mic on if you don't have noise at your end. Come on, come on, come on. No one? Okay, come back then, man. Then Yusuf. I'll not call out their names.
Yeah. Hi.
All right, let's try this question. Again, first, why don't the two of you read? Obviously, everyone read the question, but why don't the two of you then afterwards explain what you've understood?
Yeah, understood.
Go ahead.
So it says the current ratio by volume of soap to alcohol to water is 2:50 is to 100, and it is to be altered so that the ratio of soap to alcohol, which is 2:50, is doubled, which means it becomes 2:100, while the ratio of soap to water is halved, which is 2:100, which is half, which means it's 2:50 now.
Okay.
And if the altered solution will contain 100 cubic centimeters of alcohol, how many cubic centimeters of water will it contain? So, should I solve it?
No, not yet. Yusuf, do you agree?
Actually, I don't.
Where?
I think that when they say the solution will be altered so that the ratio of soap to alcohol is doubled, it doesn't mean 2 to 100, it means 4 to 50.
Oh,
Ratio doubled. What does that mean? Let's say, we have to double a ratio. X is to Y. What would be double of this ratio?
oh, 2x is 2y. Yes, I'm so sorry.
It'll be 2x to Y, not X is to 2Y. So,
It's 4:50.
so would it be 2x to Y? Would it be X to 2Y? Or would it be 2x to 2Y? And my pen is gone again. Here, 2x to 2y.
2x to y. Since 2x to 2y is the same as x to y. So
Okay, everyone, what do you think? I got what Manit you think and Yusuf. If we say that the ratio is doubled, would that mean it's the first one, the second one, or the third one? Or if there's something else which I missed out? More, I'd like more answers. Okay, so at least no one selected the third one. How does the third ratio compare with the main ratio? 2x to 2y, how does that compare with x to y?
It's the same.
Those are the same. Okay, so double obviously doesn't mean that I just multiply both sides by 2. All right, that much is sorted. One person said that double means that it would be x is to 2y. Is that doubling the ratio? Is that now doubling it or halving it? Let's think of a ratio like a fraction. So x is to y, let's think of like this, x upon y. So would doubling this fraction mean we're making it 2x by y, or are we making it x by 2? I'm sure we get that doubling this fraction would mean we're multiplying the numerator by 2. In terms of ratio, it would mean multiplying the left one by 2. Yeah. So, yeah. Now, again, so the solution will be altered so that the ratio of soap to alcohol is doubled. What would become the new ratio of soap to alcohol?
4:50.
And what about the other one?
Since it's 2:100 right now, it will become 2:200 or 4:400. Since the new.
I get what you're doing. All right. Why don't you all take a minute, 2 minutes, or whatever, take some time to solve it. Once you're done, just type in your answers in the chat window. Yusuf and Mane.
My answer is E.
Okay, Mane.
Yeah, same.
Yeah, I think everyone in the chat windows also typed the same answer. So there's not a lot left to actually discuss here, I don't think. And see, so the key here, or main things I think here would have helped, or were things that we had to keep in mind. One, Manit, you can tell us what was the first thing that we had to keep in mind.
That it's x and not y, or the numerator and not the denominator. That
What really does doubling a ratio mean?
Yeah.
Right. Also, understanding exactly what ratios are getting doubled or halved. So soap to alcohol and then soap to water, not alcohol to water. Right. So just keeping a track of exactly what ratios are getting doubled, exactly what ratios are getting halved, and in what sequence the ratios are presented in the question itself. So what does the 2 represent? What does the 50 represent? What does the 100 represent? So basically continuing with that, reading very clearly and carefully skill that we've been discussing from pretty much the first day. All right. Indeed, E is the answer here. I think everyone who put in the chat their answers in the chat window also answered E. So I think there's no need to spend any longer on this question. All right, let's continue. Let's do one more question. Here's the question. And this time, instead of Manit or Yusuf explaining it first, why don't you all go ahead and solve it completely, share your answers, and then we'll discuss.
Yeah, Anish, I think it should be C.
Okay.
Yeah.
Let's give it 30 seconds or maybe a minute more. I think I see 1A, 1D, or no, I'm finding it difficult to keep a track. But yeah, mix of. Okay, here we go. 1A, 3 Ds, 1 B, and 2 Cs. What about you, Yusuf?
Still doing something.
Okay, 15 seconds, guys, then let's discuss. All right, all right. If you're still working, just take a pause. Let's discuss together. What stage are you at, Yusuf?
No, I think يعني, my method, I think it's wrong because the numbers don't work.
Answer's not
So let's just Manat can start, or you can start by explaining the question first.
No, why don't you tell us what you understood and how you went about it?
Okay, so the first thing is that the hiker is walking at a constant rate of 4 miles per hour.
Continue.
The cyclist is traveling the same direction at a constant rate of 20 miles per hour.
Okay.
So basically, the cyclist is 5 times faster than the hiker.
Yeah.
So the cyclist stops to wait for the hiker 5 minutes after passing her.
Mm-hmm.
This is the part where I got lost, that I don't understand what does he mean by 5 minutes after passing her.
What do you think?
And then I think that it means that he passed her, and then 5 minutes after he stopped.
So the cyclist, how do we draw a cycle? Yeah, that's good enough. The cyclist and the hiker, are they going in opposite directions or are they going in the same direction?
Same direction.
Same direction. All right. So initially the cyclist was behind the hiker. At certain point, the cyclist crossed the hiker. Excuse me. Right?
Yeah.
Let's call that, or let's denote that point here. This is where this hiker is, and at the same time the cyclist is also at the same place. So, and let's say that this time is 11 a.m. let's say. What's happening next, Yusuf?
He cycles for 5 minutes and then he stops.
So what is the time then?
What is what?
What's the time when the cyclist stopped?
Plus 5 minutes after.
11:05, right? Let's say plus 5 of what? Plus 5 to what?
Yeah, plus 5 of 11. 11:05. Okay.
Okay. All right. So this is fine. Then there's no problem here. You said you're not clear. Then what? What did you do next?
And then so I calculated the distance covered by the cyclist in those 5 minutes.
Tell us.
So basically, it's, if he does 20 miles in 60 minutes, then in 5 minutes he does 1.6 mile.
Let's keep it in fractions. Why go?
Okay, 10 over 6.
Or 5/3?
Yeah, 5/3.
So from this point, whatever this point was, from this point, the cyclist has gone 5/3 miles further and stopped. Is this clear to everyone? That from the point at which the two met, cyclists rode his cycle for 5/3 miles more. 5/3, is that correct? 20 miles, 12, 5 minutes. So 20, 12. 5/3. Yeah, that's good. Do you guys all get where this 5/3 miles came from? Okay, what next, Yusuf?
And then I went and calculated how much time will it take the hiker to walk 5/3 miles.
Right. How would we calculate that?
So we do 4 miles in 60 minutes.
Okay.
So it's going to be 60 times 5/3/4.
Explain to us. How did you get this?
Cross multiplication.
No. So what exactly? So 4 miles in 60 minutes. What then?
So how much time would it take him to cover 5/3 miles?
Okay. So for 1 mile, how much time would it take?
60 over 4.
And then for 5 over 3 miles, 60 over 4 times 5 over 3. Right? That's what you're saying?
Yes.
Okay. Then what?
Anish, I think there's
No,
one.
I actually, I don't know where it blocked here. So now it's 5 times 5 equals it's 25. The answer is 25 minutes.
So, but then where were you getting stuck?
Maybe because I'm writing on a piece of paper. It's not. I messed up when writing, so I got mixed up.
Your calculation was even less readable than my handwriting on a computer screen?
Oh yeah, it's much. My handwriting is much worse.
All right. Yeah, Manit, I think I know what you're about to say. So for you, Yusuf, is the answer 25 now?
Yes.
So what does this 25 represent?
It represents the time that the hiker shall cover 5 over 3 miles.
Okay. What's the question asking us for?
How many minutes must the cyclist wait until the hiker catches up?
Is that the same thing?
No.
What's different? What's different, Manit?
That during the 5 minutes that the cyclist is cycling, the hiker is walking as well. So we have to take that into consideration.
Oh, yeah. Okay.
Right. So again, the question is, how many minutes must the cyclist wait? So cyclist stopped at 11:05. If we are assuming that the initial time was when they met was, or when they crossed was 11 o'clock. Then the cyclist stopped at 11:05, and the hiker was already walking for these 5 minutes also. So it's not like at 11:05 the hiker is at the point where they were when they crossed each other, or when the cyclist crossed. In those 5 minutes, the hiker has walked a little bit also. Do we need to calculate the distance the hiker walked in these 5 minutes? Manit?
So the distance traveled by the hiker will be 4 by 60 into 5.
Not my question. Do we need to calculate that distance?
We do, yeah.
Okay. What if I tell you we don't?
I'd be intrigued.
So overall, from the point that the bicyclist, that the cyclist crossed the hiker, how much time from that point? 11 a.m.
I agree that we don't, Anish.
Why is that?
Because there's only one answer that is more than 25.
No. Forget that also. Oh, really? So would you have taken more than 25 minutes?
Oh, sorry. I got mixed up. No. No.
All right. So see, at 11 o'clock, the cyclist passed the hiker. From 11 o'clock, the hiker would have taken how long to reach that meeting point where the cyclist is waiting? Or see, let's call this. Yeah, I need to do a better job drawing it. Let's try again. So let's say this is 11 a.m. and this is the path at 11 a.m. Both those people are here. The hiker is also here and the cyclist is also here, right? Now, this is the final point where the cyclist is waiting. What's the distance from that meeting point to the final point? 5 by 3 miles.
Yeah.
We already calculated that the hiker would have covered this distance in 25 minutes,
Yeah.
right? So at what time would the hiker have reached the final point?
In 25 minutes. So we can just subtract the time then.
Exactly.
25 minutes.
Exactly. He'd take 25 minutes from the point when the cyclist crossed the hiker. However, while the cyclist was cycling, the hiker was walking also. So he's already walked for 5 minutes. Out of the total 25 minutes, it would require him to cover the entire distance. So if he's walked for 5 minutes, out of the required 25 minutes, how much must the cyclist wait until the hiker catches up?
20 minutes.
20 minutes, 25 minus 5. So we actually don't need to calculate the distance that the hiker had traveled in the 5 minutes, right? If we just think about it again, if we visualize what's going on, so the cyclist has passed and the hiker is walking also for those 5 minutes. If we get into the maths, we might think that we need to calculate the distance, but then we've already calculated that total it would take him 25 minutes to cover that distance. Of those 25 minutes, he's already covered 5 minutes worth of distance. So that leaves us with 20 minutes that the hiker would require to, at this point, catch up or meet the cyclist. In other words, the cyclist must wait for 20 minutes. Make sense? Everyone, does that make sense?
Yeah.
Yes, no? Okay, let's look at things one more way. Let's look at things one more way. What's the ratio of their speeds, Yusuf and Manat?
1 to 5.
So, okay, cyclist to hiker, 5 to 1.
Yeah.
What would be the ratio of the time taken to cover any distance?
The same.
What do you mean same? If the speed is in the
Yeah,
ratio 5 to 1, then the time would also be in the ratio 5 to 1?
It will be 1 to 5.
Oh, yeah, that's what I meant.
Yeah, it'll be the inverse, right?
Yeah.
Is this clear to everyone? And let me
Yes.
clear the previous one. So if their speeds are in a ratio of 5 to 1, then the time that they would take would be in the ratio 1 to 5. How long did the cyclist take to cover that last leg from the meeting point till the waiting point?
5 minutes.
So how long would the hiker take to cover this distance?
25 minutes.
And he's already walked for 5. Oh,
Oh, yeah.
that leaves us with 1. Do you see?
Understood.
Right? You'd be surprised how many official questions can be answered if we just think about things logically. No, that this it's got nothing to do with me, Mayank, and no. I mean, see, if you think that it was something which I was able to do because I am very extremely smart or I have something built into me, then anyway, then the purpose gets defeated. I hope you guys can understand that we can all actually do this if only we start thinking in this direction. Right? My objective is certainly not to highlight how smart I am or how well I can do things. And that completely defeats the purpose then. But then obviously it's not like it was a very easy thing to realize, but once we start thinking in that direction, you'll surprise yourself. You'll surprise yourself on how many questions you can actually just looking at things logically understand what's really going on. So 2 aspects, the layer of logic, and the other thing I always say, visualize. It was very easy to visualize in that mixtures question that we were discussing as to what's really going on, because we've actually experienced it. But that wasn't the only thing we've experienced. We've all experienced speed, distance, time, and all these things in our life also. Yet often we find that straight from the question, we jump into the mathematics of it all. Whereas if we just applied ourselves, things actually would become a lot simpler for us and effortless, actually. So yeah, Pritesh, actually that's a good word, effortless, because we'll save time, we'll save our mental energy, right? And so many people talk about how they get completely burnt out, or they get this fatigued by the time they're done with the test. The more questions we are able to handle this way, the less fatigued we'll feel, and will take less time also. Can we do this on each and every question on the GMAT? No, of course not. I'm not saying that. Yet, we can do it on a lot more questions that you might imagine if you aren't thinking along these lines. So what I would urge for you guys to do going forward is not simply be happy once you have got an answer using one approach, no matter what the approach. Even if your answer is correct, go back to the question and think how else you could have answered it. You'd be surprised how many times, how so many questions can actually be answered in multiple ways. Even within the mathematical way. For example, Manit, you and a few others also first calculated the distance for the 5 minutes, and then subtracted that from 5 by 3, and perhaps then got the final time, right? So even there, once we actually visualize what's really going on, we were able to save some time there. But if we actually, instead of creating an equation in the first 30 seconds of reading the question itself, if we thought about things, it's possible for each and every one of us that we might actually see some or another way of doing things also. And this is a 700 level question. It's not an easy question. All right. Any questions with regards to this question that we just discussed? Or if you got what both the ways that we discussed, click on yes, please. Okay. All right. Kush, I remember about the notes. And could I explain the second way? Sure, let's do that quickly. The speeds, Kush, why don't you turn your microphone on, and let's all thank Manit and Yusuf. Today, at least, I don't think I'll ask you guys again, but you might be needed again tomorrow. By the way, tomorrow we'll get into data sufficiency, which is something I think pretty much everyone pointed out when we discussed what are the pain points in quant. So be sure you're all here tomorrow. Obviously, I'll send that email, and I'm sure Christiana and Muthu will add into the group also, WhatsApp group. So yeah, hopefully we see more people turn up tomorrow. Anyway, whoever does, I'm sure it'll be very useful. Quickly, Kush.
Yeah, hello. Can you hear me?
Yeah, I'll explain quickly. The ratio of their speeds is in the ratio of 5:1. Therefore, the times would be in the ratio 1:5.
Yes.
If the cyclist takes an hour to cover a distance, the hiker would take 5 hours to cover that.
Correct.
In the end, from the point the cyclist crossed, the cyclist rode his cycle for 5 minutes.
That's right.
The cyclist covered in 5 minutes, the hiker would have covered in how many minutes?
25 minutes. That's
25.
Yeah.
So till this point you got. Now, the question is, how many minutes must the cyclist wait?
Yes.
Let's say they crossed at 11 o'clock.
Correct.
The cyclist reached his ending point at 11:05. At what time would the hiker reach the ending point?
He would reach at 11:25, but since he is walking already for 5, then I think that's how we got 20, if I'm not wrong.
So he'll reach at 11:25, which is correct. The cyclist reached the ending point at 11:05. So from 11:05 till 11:25, how long did he wait?
20 minutes.
That's how we got 20 minutes.
Okay. Thanks.
Right? Okay. All right. Yeah. Let's see about the verbal notes, the RC notes. Any question with regards to quant that we've discussed today? Anyone? I guess not then. And I'll take those minutes. And how many of you have been present in all sessions so far? Or let's say out of the 12, let's say more than 10. Okay, okay. Yeah, I know Christiana, you've attended all. Yeah, and Muthu has also. And I did get a feedback form filled from a few. Again, I don't think all of you would have filled it, but I did get quite a few of you have given some feedback. So obviously, I understand a few things that need to be worked upon if I need to do more such workshops. But overall, so far, and again, this might be just repeating myself, but I would like to get a sense in person also, and you can type your answers or feel free to turn your microphones on. And in fact, we can stop recording for this bit, Muthu and Christiana.